For decades, science fiction has sold us a very specific dream of colonizing the outer solar system. We picture ourselves living in sleek, aerodynamic, floating cities, suspended high above the clouds of gas giants in perfect, futuristic luxury. But Jupiter has no solid surface to build on, and its atmosphere is an actively hostile thermodynamic nightmare. Anything descending into these clouds is met with crushing pressure, violent thermal gradients, and supersonic wind shear. Even if you could survive the weather, there is the gravity problem. Jupiter pulls at 2.5 Gs. The energy required to generate enough continuous lift to keep a heavy metal habitat from falling into the core violates any realistic energy budget. And if you look at this photograph of Jupiter, what you can't see is the ultimate deal breaker. The planet generates a magnetosphere so intensely radioactive that lingering in the upper atmosphere would literally liquidate human DNA in a single afternoon. Attempting to live directly inside Jupiter is absolute suicide. If humanity is going to tap into the resources of the Jovian system, we have to look for shelter on the surrounding moons, which raises an obvious question. If the planet is a radioactive death trap, why are we bothering to travel hundreds of millions of miles to get there at all? The answer is helium-3. It is a light, stable isotope that serves as the ultimate fuel for second-generation aneutronic nuclear fusion, the kind of power source that can run an entire interplanetary empire without generating radioactive waste. Earth has almost none of it, but Jupiter's atmosphere holds massive primordial solar concentrations of the isotope. It is the most valuable gas station in the universe. To harvest that fuel without getting trapped in Jupiter's massive gravity well, we need a viable staging ground nearby. We have to begin a morbid real estate hunt across the Galilean moons. We start our property tour at Io, the closest major moon. Looking at this image, you can see its hyperactive volcanic surface. Between the geothermal heat and the ability to siphon limitless electricity directly from Jupiter's magnetic field, the energy potential is massive. But this chart shows the fatal flaw. The lethal human limit for radiation exposure is around 500 rems. Io is blasted with 3,600 rems every single day. A crew would receive a lethal dose before they finished unpacking their lander. Moving further out, we have Europa and Ganymede. As you can see in this composite image of Europa, these worlds are encased in ice, harboring massive subsurface oceans. Ganymede even generates its own personal magnetic shield, which sounds like a massive perk. Yet, even with that magnetic shield, the ambient radiation on the surface of both moons will still kill you. You cannot walk outside. This cross-section of Europa's ice shell reveals a grim reality. A human habitat must be buried 5 meters deep just to block radiation. Once buried, you rely on 100% closed-loop life support. Oxygen is scrubbed from plants, and drinking water is recycled sweat and urine. Europa and Ganymede offer incredible value for scientific research, but forcing thousands of industrial workers into highly shielded subterranean isolation makes them terrible locations for a bustling logistics hub. That brings us to our final stop, Callisto. Here is a full-disk photograph of a dead, frozen, heavily cratered rock, and it is absolutely perfect. Callisto's winning feature is its distance. It orbits far enough outside Jupiter's main radiation belt that the surface experiences only a tiny fraction of the radiation found on Earth. You can actually build on the surface. Looking at this NASA HOPE mission collage, you can see that aerospace engineers have already officially identified Callisto as the ideal anchor point. It has the raw materials to support a surface habitat and an in-situ resource utilization plant to manufacture propellant. But that brings us to the heist. If we set up our primary base all the way out on Callisto, how do we actually steal the helium-3 deep inside Jupiter? The plan relies on trans-atmospheric skimming vehicles. These specialized ships drop from orbit, aggressively dive into Jupiter's upper atmosphere, scoop up the helium-3 gas, and then execute a massive burn to climb back out of the gravity well. An absurd commute like that requires a propulsion breakthrough. That comes in the form of direct fusion drives, engines utilizing nuclear fusion to provide massive thrust while generating electricity needed to run the ship. Callisto functions as the essential low-radiation anchor point that makes harvesting Jupiter physically possible. The colonization of the Jovian system requires a highly coordinated symbiotic moon network. This map of the Jovian system outlines how it actually works. Callisto serves as the gas station and staging hub. Ganymede acts as a shielded subterranean factory, and Jupiter is the deadly mine that we occasionally drop down to rob. We spent decades dreaming of space exploration as a majestic, luxurious expansion of human civilization. The reality is heavily shielded, functional, and intensely industrial. Becoming a multi-planetary species means relying on impossibly complex machinery to eke out a survival in extreme, hostile environments. We will not conquer the Jovian system by floating gracefully above the clouds. We will survive it by hiding under the ice, working in the dark, just to keep the lights on back home.